Good day. Welcome to the second video on chapter 1.5. Just a quick summary what we learned in the previous video. If we want to talk about angles, we need two rays originating from the same point. So let's say we have ray 1, which is a set of points, a plus tp, where t is greater or equal to 0, and ray 2, r2, which is a plus tq, where t is greater or equal to 0. Where P and Q are non-zero vectors. Very important. P and Q are non-zero vectors. Then we say that P dot Q is equal to the norm of P times the norm of Q times cos theta, where theta is the angle between the two rays. So we learned that we can define angles in not just 2D, but in any dimensions that you are playing with, but we'll mostly be playing with 3D. Alright, now the next thing that I want to look at in this video is triangles. Alright, how would we define triangles in our model? Alright, so we know that a triangle, you have three vertices. So say we have three vertices A, B, C, and let them be 3 points in R3, not on the same line. Very important. You've got to have 3 points in R3, not on the same line. And so now we talk about segment 1, which is the line segment from point A to point B, line segment S2, which is the line segment from point B to point C, and line segment S3, which is the line segment from point C to point A. So the triangle with vertices ABC is the set, which is the union of the three line segments given. All right. It's better to demonstrate this with a picture. So imagine this in 3D. So you have 3 points in space. Doesn't matter where they are in space, as long as they do not lie on the same line. All right. So now what we do next is for any pair of points, we construct a line segment between those points. All right. So we get S1, which is a line segment. It's not a line, it's a line segment. S2, which is a line segment, and S3, which is a line segment. So the triangle is the union of these three line segments. All right. Remember, S1, S2, S3, these three line segments are the sides of the triangle. All right. So this is all nice and dandy, but what about angles? All right. So we know that a triangle has got three sides, and it's got three vertices, but it also have three angles. All right. So how do we work out the angles? And as we saw from the very first video in part 1, is we need to construct rays. So we're going to talk about the angle at A, the angle at B, and the angle at C. All right. And this is how you do it. You construct rays. All right. So if you want to talk about the angle at A, you form rays R1 and R2. Ray 1 starts at point A and passes through point B. Ray 2 starts at point A, passes through point C, and the angle at A is the angle between ray 1 and ray 2, as depicted in here as the blue angle. All right. If you want to talk about the angle at B, so what you do is you form a ray R3, starting at B, passing through point A, R4, ray R4, starting at B, passing through point C, and then this green angle is the angle between ray R3 and R4, which is the angle at B. All right. And if you want to talk about the angle at C, first construct two rays. Ray 5, which starts at C, passes through point A. Ray R6, starting at C, passing through point B. And the angle between ray 5 and ray 6 is the angle at vertex C. All right. So this is wonderful because now we can define what angles of a triangle is. All right. So you see, to do this, we had to construct 6 rays in total. All right. But how do you do the calculation? All right. So if you have the equation of the rays, then it's easy. All right. We get to use the formula P dot Q is the norm of P times the norm of Q times cos theta. But what if you're given the vertices A, B, C? Can you come up with a formula for the angles? All right. And the answer is yes. All right. And the secret is to think back to high school. In high school, we had a version of the cosine rule. All right. In 2D. So if you have a triangle with vertices A, B, C, then the opposite sides are labeled little a, little b, little c. And then we have the angle at B, we have a formula for it, which is little b squared is c squared plus a squared minus 2ac cos b. This is the cosine rule, which we learned in high school. But our model is so wonderful, we can now even have a cosine rule in 3D or as many dimensions as you want. So let's say the angle at B is called theta. Then you can prove that the distance from A to C squared is equal to the distance from A to B squared plus the distance from B to C squared minus twice the distance from A to B times the distance from B to C times cos theta, where theta is the angle at B. All right. If you're curious about the proof is on page 36 in your textbook, so do have a look at it. All right. So we can have lots of fun with triangles, and you should also have lots of fun with triangles. So do try out exercises 1.5.10 to 1.5.13. All right. But I've decided I want to do exercise 1.5.13. All right. This is a nice little exercise. All right. So imagine you have 3 planets, A, B, C. And you know that the distance from planet A to B is 3. That is, the norm of point A minus point B is 3. And you know the distance from planet C to A is 4. That is, you know that the norm of vector C minus vector A is 4. And if you're at planet B and you use your telescope and you measure the angle between the 2 planets is pi over 6, that is, the angle at point B is pi over 6, is this enough information to work out how far planet B is from planet C? That is, can you work out the norm of vector B minus vector C? And the answer is yes. All that you do is you apply the cosine rule. All right. So we have the angle at B, which is pi over 6. So we can say by the cosine rule, we have the angle opposite B, which is the norm of A minus C squared. That is equal to the norm of A minus B squared plus the norm of B minus C squared minus twice the norm of A minus B times the norm of B minus C times cos of pi over 6. All right? So it's a lot of writing. Make sure on top of every A you put a line. On top of every B you put a line. And on top of every C you put a line. All right? Because A, B, and C are vectors. And now we start filling in. All right? So know that the distance from C to A is the same as the distance from A to C. And that's given as 4. All right? And we also know that the distance from A to B, that is equal to 3. And I'm going to make my life easy. I'm going to say let the distance from B to C equal to x. All right, so now let's fill in. The distance from A to C is 4. And so this becomes 4 squared is equal to the distance from A to B, which is 3 squared. The distance from B to C, we called it x, so that's x squared minus twice the distance from A to B, that's 3. The distance from B to C, it's x, and cos pi over 6 is a special angle. And as I said in the previous video, like you know your name, you got to know what cos pi over 6 is without even thinking, and that is root 3 over 2. All right, so now we simplify, we get 16 is equal to 9 plus x squared. This we can simplify, and if we simplify, this becomes minus 3 root 3x. And now we can rewrite this as x squared minus 3 root 3x minus 7 equals 0. So what we have here is a quadratic equation, all right? So yes, you can factorize, but I'm not going to bother to factorize because it looks difficult because the coefficient of x is minus 3 root 3. So I'm going to use the formula. So I know that x is equal to minus b plus minus the square root of b squared, which is 27, minus 4ac divided by 2a, which is 2. So this becomes square root 27. So 3 is root 9. Root 9 times 3 is square root 27. Plus minus, this is 27 plus 28, which is square root 55 over 2. I don't have a calculator, so this is my answer. So I see 2 options. So I see x is equal to the square root of 27 plus the square root of 55 over 2, which is good. And it works. Alright. We also get that x is equal to the square root of 27 minus the square root of 55 over 2. And this is negative since 27 is less than 55. And what does that mean? That means that, and so the square root of 27 is less than the square root of 55. And so the numerator is negative, and if the numerator is negative and the denominator is positive, it's negative. And this is not possible. Why? Since x is equal to, remember, x is the distance from B to C. So x is the norm of B minus C, and we know that the norm is greater or equal to 0. So remember, the norm of any vector is greater or equal to 0. So this solution, not valid. And now let's finish it off and say, sorry about that, need some more space. Say the only answer is that the norm from B to C is equal to the square root of 27 plus the square root of 55 divided by 2. And there you go. I hope you enjoyed this short video, and you're going to try the exercises in the textbook, exercise 1.5. There's lots of exercises working out angles and even playing with triangles. So for example, if you know that all of the sides are equal, then it means that all of the angles are pi over 6. So this means that the way we've defined things are doing very well. This is the end of the video. Please come back for the next video, which will be on chapter 1.6.